Hey guys, Travis Gillespie here. We're working with functions. Here's another example to look at. It says the school choir tracked the number of tickets sold and the total amount of money received. The choir members received $80 for 20 tickets, $88 for 22 tickets, and $108 for 27 tickets. If each ticket costs the same, write an equation for the function. Okay, let's highlight this key information from this problem. The first thing I see is that the choir, they're tracking the number of tickets sold, also the total amount of money received. Money received. The members, they received $80 for 20 tickets, $88 for 22 tickets, $108 for 27 tickets, and if each ticket costs the same, this is key right here, so I'm going to highlight that each ticket costs the same. We want to write an equation, so also write an equation for the function. So I'm going to break this problem down into two steps. Step one, my first step, I want to create a table. After I create a table, my second step, what I want to do is let's create the function second. So let's start on that table real quick. Now you might remember from watching previous videos that we had the independent variable, that x value, on top. So I'm just going to put an x to the side because I'm not necessarily going to use an x for every single table I create. In fact, this table I want to use something different. And I'm just going to put a t on the inside of this table. So remember, the t, it's our x variable, but it stands for the tickets sold. So anything I'm writing outside of this table right now, I might not necessarily write it in the future. So tickets sold. So this is my x variable. And my y variable, or my independent variable, again, I'm not going to put the y on the inside. I'm going to put an m on the inside. And this m stands for the money received. So I'm just going to use a dollar symbol outside, just so we know m stands for the money received. In the future, you won't have to write this information on the outside. So going back to the word problem, we see that when 20 tickets are sold, $80 was received. So I'm going to put 20 tickets. When 20 tickets are sold, then $80 is received. And I can put a dollar sign inside of my table if I want to, but I don't necessarily have to. And now let's just pause for a second and see if this really holds true, as the tickets being sold being the independent variable and the money being sold being the dependent variable. So the first thing, the way I could read this to myself is to ask myself, does the amount of tickets sold depend on the money received? Not necessarily, and it even sounds a little bit funny saying it. So let's just reverse those two. Does the money received depend on the amount of tickets sold? Yes, and that statement or question even sounds more clear. So the money is definitely the dependent variable. Okay, let's move on to filling out the rest of this table. We can see that when 22 tickets are sold, $88 is received. Again, you don't need to put that dollar sign in the cell if you don't want to. And finally, when 27 tickets are sold, $108 was received. So 27, 100, that should be 108. Okay, so we've created a table. Now the second goal is to create a function. And the reason we're going to create this function is because we want to find out how much money is generated with tickets being sold, or can be generated with tickets being sold. But in order to create a function, I need to find the unit price. So I'm going to change colors and write unit price here. And remember, the unit price is how much money it costs for one single unit, for a quantity of one. A good example to use is always thinking about buying gas to fill up a car tank. You always think about that unit price as the price per gallon. So guess what? A unit price is equal to, we're going to put the money on top and the quantity on bottom. QTY for short, for quantity. Now let's just pause for a second. We're going to be real careful here. And let's sort of just bubble this up in its own little cloud. I want to be really careful when I start plugging values in to find out my unit price, because I'm going to use values from this table. If you notice in the unit price, the value in the numerator, or the value on top, the value that comes first, it's a dollar sign, it's money. But if we look in the table, the values that belong or correspond to the money run along the bottom. So just be sure that you're matching up the correct information before you start any calculations. So it looks like the money, although it's on the bottom in the table, I've got to put it on top for my unit price. So I'm going to go ahead and just create a fraction bar. I'm going to use this first value, $80. I'm going to put 80 on top, which means the quantity, the number of tickets sold for $80 is 20 in the table. So again, 20 is on top in the table. However, I'm going to match it up with the information from my unit price. Quantity, or number of tickets in this case sold, is on bottom. So 20 will go on bottom. So you receive $80 per 20 tickets. This can be simplified. Well, 80 divided by 20, let's go ahead and write that below. That gives me a value of $4 per every one ticket sold. So $4 per every one ticket sold. So we can create a function based off this information. I can find out how much money can be generated by the number of tickets sold now. So let's start working on this function. I'm going to choose a black pen here. I know that the money, or M, is equivalent to $4 for every ticket. So $4 per every ticket sold. And I'm going to use a variable and I'm going to use this variable t for the number of tickets sold. So if I multiply 4 times 20, I'll get $80. If I multiply 4 times 22, I get $88, and so on and so on. I could plug any value into t, or the number of tickets sold, multiply it by 4 to find out how much money can be generated. So I can box this information up. It's good to go. I'll see you in another video.